In this video, we will learn how to solve rational equations such as these. We will solve them by hand, algebraically, but we will also learn how to solve them using a graphing calculator or other technology like Desmos app or Desmos.com to solve them graphically. Okay, our goal is to solve for x, to get x by itself. Every problem is a little bit different, so we're going to use a variety of tools and techniques. When you have something simple, like just a fraction equal to whatever, we're going to cross multiply. Now what that means is, in this case, we can look at -6 as -6 over 1. When you have a fraction equal to another fraction, you can make an equivalent expression. You can make a new equation by doing this. You can make one side of the equation by multiplying this diagonal together. So usually I skip this step, but I'm going to just show it for right now. I'm doing -6 times x plus 5. And then the other diagonal, in this case, is just 3 times 1. So usually I skip this step and I just do the distributive property immediately. So this would be -6x minus 30 is equal to 3. So now that the fraction is gone, it's easy to get x by itself. We're going to add 30 to both sides. And that will give me -6x is equal to 33. Then I'm going to divide both sides by -6. Now I'm reaching for my calculator because ultimately I'm going to have a decimal. But for right now, I have -11 halves, which of course as a decimal is -5.5. Now the main reason why I need a decimal to look at is because I want to see how we can solve this graphically using our technology. And our technology is definitely going to give us a decimal. So for right now, I'm going to solve this problem again using Desmos.com. Alright, so here we are at Desmos.com. Now the way I could do this using my technology is, when you look at this equation, you could break this up as two separate equations, like two separate functions. So I could look at this as y equals 3 over x plus 5, and I could look at this as the equation y equals -6. If I graph both of these functions and see where they meet, in other words, I'm seeing where they are equal, because these are supposed to be equal to each other, then the x value will be the solution to the equation. So that's my strategy. So I'm going to type in 3 over x plus 5. Okay, so I can type y equals, and I can do 3 divided by x plus 5. And you can see it's graphing it for me. And then the other equation was y equals, and I believe it was -6. Let me just double check. Yep. Okay, and that's going to be a straight line, a horizontal line at -6. So I might have to scroll a little bit. Alright, so we see the red function is the first equation and the blue function is the second equation. The point of intersection is right here. If I could just, okay, there it is. So you see the point of intersection is at -5.5 comma -6. And the -5.5, that x value is the same solution that we got the first time. Alright, so that is how you can solve a rational equation using a graphing calculator. In this case, Desmos. Let's do the same thing with number 2. Again, when you have a fraction equal to a fraction, you can cross multiply. So I'm going to take this, which is x times 2x minus 3, and I'm going to set that equal to this, which is 2 times x minus 1. You can feel free to skip this middle step and go straight to 2x squared minus 3x is equal to 2x minus 2. So to solve this equation, we will get 0 on one side. So I'm subtracting 2x from both sides, and I'm adding 2 to both sides. So that's going to give me 0 over here. On the left side, I'm going to have 2x squared, just bringing that down. Negative 3 and negative 2 make negative 5x, and then plus 2. So I have this. Now, either I will factor this or I will use the quadratic formula. I'll try to factor it real quick. If I try to factor this, 2x squared can only factor as 2x and x. 2 can only factor as 1 times 2. And then I think inner plus outer must equal middle. Inner, I have 1x. Outer, I have 4x. I'm trying to get a middle of negative 5. Both of these would have to be negative to make negative 5. And then that does give me positive 2. A negative times negative is positive. So we were able to factor it. So I don't have to use the quadratic formula. But just remember, if it doesn't factor, don't panic. Just use the quadratic formula. So to finish the problem, I need to take each of these factors and set them equal to 0. So 2x minus 1 equals 0, and x minus 2 equals 0. This will give me 2x equals 1, and x equals 1/2. And of course, this will give me x equals 2. So these are the two solutions for this equation. So that's how we do it algebraically. Now let's see how we can use Desmos to do it. And again, I'm just going to do the same thing I did before. I'm going to make two equations. One of them will be y equals this side, and the other one will be y equals this side. And wherever they meet, the x values will be the solutions. So I need 2x minus 3 over x minus 1. So that's the first equation. The second equation, I need 2 over x. So I'm doing 2 divided by x. Alright, so I get this crazy looking graph, and I want to see where they intersect. Okay, seem to have a hard time. Okay, that's one intersection point, and here's another intersection point. So it's the x values, so 2 and 0.5. So there's my 2 and there's my 0.5. Alright, look at number 3. Again, I can just cross multiply for this one. So I'll get one equation by multiplying this diagonal. So that's going to give me 4x squared minus 36. I went ahead and just did the distributive property. And then 1 times x squared is x squared. Okay, so I cross multiplied. Now, I can get 0 on one side by subtracting x squared from both sides. So that's just going to give me 3x squared minus 36. is equal to 0. Now, there are a couple different ways I could solve this. I could factor this, which I think I'll try first. If I factor this, in this case that means pull out the common factor of 3. That's going to leave behind x squared minus 12. But then I'd have to, this won't factor any further, so I would have to set x squared minus 12 equal to 0. Normally I'd set the other factor equal to 0, but it's a constant, so it can't equal 0. So x minus 12 has to equal 0. Adding 12 to both sides, then let me move it over here. That gives me x squared is equal to 12. So I'll have to finish this by taking the square root of both sides. Now, when you take the square root of both sides of an equation, the solution could be positive or negative. So put plus or minus. So the square root of 12, let's see, 12 is 4 times 3, so that's going to be plus or minus 2 radical 3. So that's two different answers, okay? 2 radical 3 and negative 2 radical 3. All right, just showing you the square root of 12 is 2 radical 3. Now, as a decimal, 2 radical 3 is 3.46. All right, 3.46. And of course, negative 2 radical 3 would be negative 3.46. I'm just putting the decimals down so when we look at the calculator, we can look for these numbers. So let's see how this would look using our technology. So again, I'm going to make one equation out of this side, and I'm going to make another equation out of this side. So let's see, x squared over x squared minus 9. So over here, whoops, I've got x squared over x squared minus 9. All right, so my first equation is here in red. And the second equation is y equals 4. So there's a horizontal line. So immediately it's showing me the intersection of these two functions. Negative 3.46 and positive 3.46. All right, the x values. All right, and that's exactly what we got when we did it algebraically. All right, now let's look at number 4. This one's going to take slightly more because it's not just a fraction equal to a fraction. I've got to deal with this negative 2. Okay, so I can't cross multiply. So what in the world am I going to do? First of all, let's factor the x squared minus 1. So I'm going to have 5x over x minus 1, and I have minus 2, and then I have 14 over, and this is going to factor as x plus 1 times x minus 1. This is the difference of two squares. Now you notice I kind of spread this out a little bit, and here's why. Anytime I want to get rid of a fraction, one way to do it is by multiplying by the denominator. So I'm looking at my denominators here. I see x minus 1, right, in two different places, and I see x plus 1. So what I can do is I can multiply everything by whatever I see in the denominator. So I see two things in the denominator. I see x minus 1 and I see x plus 1. That's all I see. So that means I'm going to multiply everything by x plus 1, like this. Because that's one of the things I see in the denominator. But I'm also going to multiply everything by x minus 1, because that's the other thing I see. So basically I'm multiplying everything by x plus 1, x minus 1. The idea is to cancel out all of the denominators and sort of flatten this equation out. So if I do that, over here on the right hand side, x plus 1 and x minus 1, they all cancel out. Nothing cancels out here, no denominator. Over here, x minus 1 and x minus 1 cancels out. So far this is what I have. I have 5x, okay, so I have 5x times x plus 1, and I have negative 2 times, now, I want to go and FOIL these together, double distribute, multiply these. If I do that, if I multiply these together to see what I get, I'm going to wind up with x squared minus 1. Remember, x squared minus 1 is where this came from in the first place. We factored it. It's the difference of two squares, x plus 1, x minus 1. So of course, if I multiply it again, it's going to give me back what I started with. So this is the same as x squared minus 1. All right, over here, everything canceled out, so I have 14. Now I'm going to do the distributive property, like this and like this. So this is going to give me 5x squared plus 5x. When I distribute this, I am distributing negative 2, not positive 2, negative 2. So negative 2 times x squared is negative 2x squared. But negative 2 times negative 1 is positive 2. A negative times negative is a positive. That is a common mistake. A lot of students would put negative 2. And then I combine like terms. So 5x squared minus 2x squared, that's 3x squared. And then I have my 5x, hello, and my plus 2 equals 14. Subtracting 14 from both sides, that gives me, let's see, I'm going to need more space. That's negative 12. Now, to solve this, I will try to factor it. If it doesn't factor, I will use the quadratic formula. But let's try factoring foist. Okay, 3x squared can only be 3x times x. 12 is either going to be 3 times 4, 2 times 6, or 1 times 12. I'm going to try 3 times 4 first. I won't put the 3 here because that would make a common factor, so I won't waste my time with that. I'll go straight to 4 and 3. Now inner plus outer equals middle. Inner I have 4x, outer I have 9x. I'm trying to get a middle of 5, so this is looking promising. To make a positive 5, I would need a negative 4 and a positive 9. So here's my negative 4, and this would be my positive 9 right here. Also, negative 4 times positive 3 is negative 12, so that is the correct factorization. Alright, now to find the solutions, I will set 3x minus 4 equal to 0, and I will set x plus 3 equal to 0. This gives me 3x equals 4, and x is equal to 4 over 3. So that's one solution. And this one gives me x equals negative 3. Alright, so these are the two solutions for problem number 4. Now let's look at it graphically and see if we get the same thing. Okay. And again, to do this graphically, I'll make one equation out of the left side of the equation. So y equals this will be one function. And I'll make another equation out of the right-hand side, y equals this. And I will look at the x values of the points where they intersect. So here you can see I've typed in the two equations. Alright, the red one is looking like this and the blue one's looking like that. I need to find the points of intersection. Alright, there's one point of intersection right there. And it looks like there'll be another one up high. Somewhere in here. Alright, it may be tricky for me to find the actual point of intersection. Alright, I found it. So one point of intersection is 1.3 repeating. Does that match up with anything we had before? Okay, so you see the 4 over 3. You got 4 over 3. If I toggle that, I get 1.3 repeating, so that matches. So that's one intersection point, just the x value, of course. And the other intersection point is down here. Keep missing it. There it is. -3. And there's my -3.